Hey Robert, how you doing? Okay, I made a couple of changes. Matter of fact, I have a couple of models I have to show you today. Um, this particular model was with the pumpkin on top, and I wanted to see what happens um, as this goes. The assumption here is the fact that these weights are separated and that the pumpkin can fit between it. But the counterweight arm is in fact a solid arm, so that's my assumption there. If I let this run, the first part of it's not very interesting. You'll notice that it's expanding nicely. There is a bit of a dampener on these two joints, but it's pretty small. So as it continues, without that dampener, incidentally, this thing will in fact hit the counterweight arm. So if I let that go a little further and and this extends very nicely. I like the way this thing is extended. And it finally releases at 84 miles an hour. So that thing is really cooking. So that was the first one. Then I remember the one I sent you had a much longer throwing counterweight arm. So what happens if I use a longer counterweight arm? And let's take a look at that. That's here. Now, I had to make an additional assumption. The dampener is still the same. It's at 20, 0.2, I mean. And the assumption here is the fact that there's two counterweight arms, and that the pumpkin can actually go between them. Okay? And that there's two weights, of course, but it's divvied up equally on both sides. And if I let this run, by the way, that previous model, that thing would be a bear to tune. It could be a little tricky. This one would be a lot easier. Basically, now you can use the flight of the sling and the pumpkin to do your tuning. And again, during the power stroke of the arm is fully extended. And it finally releases, and it's going 85 miles an hour. So there wasn't much of an improvement as a result of that. But I also noticed here that the golf ball actually slowed down this throwing arm quite a bit. If this was a pumpkin and a real throwing arm made out of metal, it probably wouldn't slow down as much. So the next question is, if you didn't have two, if you only had one, what would it look like? And I went to here. Now this is assuming the fact that there's a pulley here, and that the rope itself will actually extend. The pumpkin is going to start its throw as a result of going through that pulley. It's going to do it a little earlier than we anticipated. So if I let that thing go, you can see here, and let me get rid of the stuff in the background, here that it's starting to head in this direction, and the pulley itself is really extending it out pretty hard. And if I let it run, I just wanted to see what would happen. It comes way down here, so the distance between the bottom of this arc and this axle is really pretty long. It's just about twice as long as the throwing arm. That's one thing I noticed. The second thing I noticed is this is nice and even. That's good, but the pumpkin, as it's coming out of here, is actually doesn't release until it's going negative. If I look at the sling angle versus the throwing arm angle, it goes actually negative. But it's going 112 miles an hour, so that thing is it's going pretty quick. So the real question is, the original throw, why was that so much better? And This is the one I sent to you a while ago. I made one change, and that is to add some air resistance in here. But this is resting on here. The counterweight arm is actually resting on the pumpkin itself, or in the golf ball in this case, and everything else is pretty much the same. So as this thing goes, and the counterweight arm is starting to extend out, there the pumpkin got released. Another thing I like about this particular model is that I can control when that pumpkin does get released, and I found with Merlin that was a really important thing. So, and I'm looking here, and the thing is actually going at 133 miles an hour. So, why is this so much different? And one of the things I noticed was right here. If you'll notice, this throwing arm is really coming around strong here. And it's coming in around strong during the power stroke. And why was that? And the reason for that is because it's reacting to the fact that the counterweight arm is extended to its fullest point here, and it's actually causing a whipping action to occur on the throwing arm. Now, this would be a nice thing to try to do, but I think in real life it would be really hard to get it to do just exactly that, and you'd have to have a lot of control over a whole bunch of variables on this particular model. I think it was just an aberration that occurred, and I wouldn't use this to build from. I guess that's all I've got for the time being. Thanks, and I'll talk to you later.